Welcome to today's paper reading. Today's paper is titled, Red Teaming Visual Language Models. This paper was published on the AR14 preprint by Mukai and colleagues from the University of Hong Kong and Zhenguang University. Vision language models, VLMs, expand the capabilities of large language models, LLMs, to handle multimodal inputs. However, concerns arise as LLMs have been shown to generate harmful content under specific test conditions, known as red teaming. This study investigates how VLMs perform in similar scenarios. To address this, the authors introduce RTVLM, a novel red teaming dataset that includes 10 subtasks across 4 primary aspects: faithfulness, privacy, safety, and fairness. This dataset is the first to benchmark current VLMs in these areas. Analysis reveals that 10 prominent open-source VLMs exhibit varying degrees of difficulty with red teaming, showing a 31% performance gap compared to GPT-4v. Additionally, applying red teaming alignment through supervised fine-tuning, SFT, to LLMs 1.5 significantly improves its performance, without compromising other benchmarks. This indicates that current open-source VLMs still require better red teaming alignment. The study's code and datasets will be made publicly available. Vision language models, VLMs, are designed to handle both textual and visual inputs, enabling a wide range of applications. The integration of large language models, LLMs, into VLMs has significantly enhanced their ability to understand complex inputs. However, despite the progress, VLM's performance in challenging scenarios remains uncertain. There is evidence that LLMs, the backbone of VLMs, can generate incorrect or harmful content in certain cases. This raises concerns about the potential risks associated with VLMs. To address these issues, the Red Teaming Visual Language Model, RTVLM, dataset has been introduced. This dataset focuses on red teaming scenarios involving image-text inputs and covers 4 key aspects: faithfulness, safety, privacy, and fairness. It includes 5,200 samples, with novel question-image pairs to ensure the test data is unseen by the evaluated VLMs. Figure 1 provides an overview of the RTVLM pipeline, detailing the processes of data collection, evaluation, and alignment. The dataset is structured to include 10 task categories distributed across 4 primary aspects: faithfulness, privacy, safety, and fairness. The analysis reveals that prominent open-source VLMs exhibit varying degrees of struggle in red teaming challenges, with a performance gap of up to 31% compared to GPT-4v. The RTVLM dataset is constructed with a specific data format. Each instance includes an image stored in PIL format, a question generated by either a human or GPT-4, and a decision on whether the model should respond to the question based on ethical guidelines. The dataset is divided into subtasks focusing on faithfulness, privacy, safety, and fairness. Data collection involves manual annotation of images, generation of similar data using self-instruct with GPT-4, and ensuring diversity by filtering out similar samples. This comprehensive approach ensures the quality and relevance of the dataset for evaluating visual language models. Table 1 provides an overview of the RTVLM dataset, detailing the creation of new question-image pairs. The images used are either publicly available or originally produced, ensuring a diverse and comprehensive dataset. The red teaming questions, which are crucial for the dataset's utility, are either annotated by humans or generated by GPT-4 based on human-written seed examples, ensuring a high level of relevance and accuracy. Figure 2 provides an overview of the 10 subtasks categorized under faithfulness, privacy, safety, and fairness in the RTVLM dataset. Each subtask is associated with specific image types and sources, such as open-source datasets like Mukai and Celeb, as well as diffusion-generated images. The annotation process involves either GPT-4 self-instruct or human annotation to ensure the quality and diversity of the dataset. This figure is crucial for understanding the breadth and depth of the RTVLM's red teaming challenges. Table 3 presents the GPT-4v scores of various visual language models, VLMs, on the Red Teaming Visual Language Model, RTVLM, benchmark. The results indicate that GPT-4v achieves the highest scores, significantly surpassing other open-source models. Among the open-source models, LLM 1.5-13b stands out for its overall effectiveness in handling the tasks. In contrast, Yuwei 8b, which has not undergone instruction tuning, shows weaker performance across the board. The table highlights the best and second-best results, providing a clear comparison of model capabilities in a red teaming context. In this section, we discuss the experimental settings used to evaluate vision language models, VLMs, on the RTVLM. We employed GPT-4v as the evaluator, following detailed scoring criteria and a specific prompt for faithfulness evaluation. Moving on to the red teaming test results, we found that GPT-4v significantly outperforms open-source models in various dimensions such as faithfulness, privacy, safety, and fairness. Despite this, most VLMs struggle with issues like identifying misleading content in mixed media and protecting privacy. Finally, we analyzed the alignment of VLMs in red teaming scenarios, noting that while some models show improvements with alignment training, the use of RTVLM as SFT data notably enhances the model's ability to handle red teaming, improving safety and robustness without compromising downstream task performance. Figure 3 presents the fairness scores and variances of various models across gender and race categories. The left panel shows gender fairness scores at the top and race fairness scores at the bottom, both ranging from 5.5 to 8.5. The right panel displays the variance, with red bars indicating gender variance and pink bars indicating race variance. This visualization helps in comparing the performance of different models in terms of gender and racial fairness without making any value judgments. Table 5 presents the human evaluation results and the inter-annotator agreement, IAA, between human annotators, human and GPT-4, and human and GPT-4v on the RTVLM test dataset. The scores are categorized into two groups, those from 1 to 5 and those from 6 to 10. Consistency is determined by whether the scores given by the models or annotators fall within the same range. Cohen's kappa is employed to calculate the IA, which shows a high level of reliability in human assessments. This table highlights the alignment between human judgments and GPT-4 versus evaluations, enhancing the reliability of the results for tasks similar to RTVLM. Table 6 presents the performance scores of the LLM series models, specifically the 7B size versions, on three benchmarks, MMBench, Hallucination, and RTVLM test. Notably, the LLM 1.5 ShareGPT-4v model, which has undergone tuning on ShareGPT-4v, demonstrates superior performance across these benchmarks. This table highlights the impact of red teaming alignment on enhancing the RTVLM performance, suggesting that current alignment datasets may not adequately cover red teaming test scenarios. The scores on MMBench and Hallucination are also detailed, providing a comprehensive view of the model's capabilities in different evaluation contexts. In the realm of natural language processing, red teaming has evolved from its origins in cybersecurity to become a critical method for testing language models. This involves both manual and automated approaches to uncover potential harms, such as offensive content and data leakage. Visual language models, VLMs, have advanced significantly, integrating large language models with vision encoders, and scaling both vision and language components. Security and safety remain key concerns, particularly with the vulnerability of VLMs to visual adversarial attacks. Reinforcement learning from human feedback, RLHF, and direct preference optimization, DPO, are being explored to enhance the performance and safety of VLMs. In this study, the authors introduce RTVLM, the first dataset specifically designed for red teaming of vision language models, VLMs. This dataset comprises 5,200 entries across 4 categories where VLMs are particularly susceptible to red teaming attacks. The authors tested current popular open-source VLMs and GPT-4v, revealing that many models are not adequately secure against various red teaming tactics, with some exhibiting strong biases. By using a subset of RTVLM for red teaming alignment, the authors successfully improved the model's performance on downstream red teaming tasks, highlighting the dataset's potential for enhancing model security. The authors hope that their work will raise awareness about the critical importance of VLM security and provide valuable insights and references for future efforts in this area. Thank you for watching.